Thank you so much. So we're going to have a mixture of short presentations followed by the panel sessions and then the question and answer. I haven't introduced, Airgain yet, so I'm going to start, with introduction of who we are for the audience here and also, the audience virtually that we're taking video for. So let's see. So the panel session, we're going to practically talk about the whole future of the wireless, the role of the 5G and the 6G next generation cellular systems. So practically everything possible, the questions will be drafted that way. And thank you so much for all distinguished participants here. And what I'd like to do when I call your name for presentation or question, give a short introduction about yourself, who you are, and then we'll move forward from that. Okay? Again, the panelists, we're missing Dr. Lars, unfortunately, due to some personal reason. He wasn't able to fly. Dr. Lars is a member of the Fraunhofer HHI Germany, and we have a long-term collaboration with HHI with Airgain for quite some time, and also Tokyo Tech had some collaboration with HHI as well. And let's see, a little background about myself. Don't want to talk about myself too much, but I have joined Airgain nearly 4 years ago. Previous to that, I was part of the Intel millimeter wave organization. I ran the R&D for Intel for quite some time. And before that, at IBM. I've been around a little bit longer than everybody else, and the gray hair, justifies the number of years that I work in the industry. Okay, so who is Airgain? A little bit history about Airgain. We were established back in 2003. We went public in 2016. We were headquartered in San Diego. We got design centers and sales and marketing organizations worldwide, and I have a slide on that as well. And we have quite a lot of patents. Initially, the company was formed based on its knowledge on antenna design, MIMO antennas, embedded antennas, external antennas. And when I joined, one of my tasks was to transform the company from a component-only antenna company to more of a system solutions. And we have completed that transformation, and you're going to see some of the products that we have launched in the past few years. This is a picture of our design centers, the sales organizations, and across the world. In the United States, we have 3 sites in San Diego headquarters, and Scottsdale, Arizona, and in Minneapolis. So this is the new Airgain. As I mentioned, in the past, we were focusing more on the antennas, embedded antennas, external antennas, but once the transformation of the technology has been completed, although we still have the expertise in the antenna, we're using that expertise to build the full system, the full end-to-end system. Some of the examples are our rugged fleet gateway product. You've been exposed already with the Lighthouse. The Lighthouse comes in 2 forms. It's a family of a product, the network control repeater, and also the small office, home office, we call it micro repeaters. Lantern fixed wireless access that has been launched last year. It is designed for enterprise applications as a high gain antenna. Again, as an expert in the antenna design, we use our expertise to build the product. And then, a series of the cellular asset tracker products as well. Some of the usage models you can see, the left picture, the lantern fixed wireless access for the enterprise, the Airgain Connect for first responders. The Lighthouse, one of the uniqueness is we can install the Lighthouse network repeater on a single pole. And the feature for that is echo cancellation and also smart antennas. There's a built-in smart antenna in the donor units. The Lighthouse Micro is used for, as I mentioned, small businesses or the homes, and the cellular asset trackers specifically for train, the cargoes, for airplane cargoes, and so forth. We talked about the Lighthouse Solar, and this one is fairly unique. We launched it officially last week. As you remember, we have done the case study with Omantel successfully, and it has quite a lot of features that it makes it a very unique product that is complementing the whole infrastructure network as well. This picture sort of like shows our product in a variety of usage cases. This is specifically a DoD project that we're involved, but you can see that the sustainability of our network repeater plus the fixed wireless access, our Airgain Connect as a mean to connect to the 5G network, and also at the same time creating a Wi-Fi bubble for soldiers or whoever is around the vehicle. And the whole network can be run off-grid or on the grid. If there is no power, we run it on the solar. If there is power, obviously it will connect into the network. So that's all I have on that side. The next speaker, Sakaguchi-sensei, yes. This is how you control it.
Okay.
So you just advance it, it goes into your presentation.
Yes.
Right.
Okay.
Thank you.
Thank you. First of all, I would like to say congratulations for the excellent partnership between Omantel and Airgain. Okay. So I'm Kei Sakaguchi from Institute of Science, Tokyo. Do you know my university? Really? So this university is very young. Less than 1 year old. Last October, two universities, former Tokyo Institute of Technology and Tokyo Medical and Dental University, unified. So that the age is very young, but history is very long, more than 140 years. Okay? And now I'm a vice president of the university and working on the research strategy of whole university, not only wireless, but also all science, technical, and medical, and dental, and nursing, and healthcare things. So I'm a right guy to talk if you want to launch international collaboration. Okay. So by the way, Ali and me have a gentle partnership more than 10 years to promote millimeter wave in both Wi-Fi, WiGig, and also 5G NR. Although he switched his focus to sub-6, I'm still accelerating millimeter wave by extending coverage with low cost and also innovating new use case applications can be done only by 5G. Okay? And today I'd like to share the latest state of millimeter wave, at least in our campus. But as he told, in Japan, all telecom operators, NTT Docomo, KDDI, SoftBank, and Rakuten Mobile, all already started millimeter wave. Okay? And then there are problems. The one is a coverage, of course, and the other one is a use case. Okay? And I talked the latest status by referring to our campus, Okayama campus. Okay, so since 2021, we have developed Okayama 5G, 6G test field in the campus by collaborating with Rakuten Mobile and also Panasonic. Okay? And this is a campus map, and everything in the blue box are inside the campus. Okay? Of course, we have RU, radio unit of sub-6 and millimeter wave, many inside the campus. Okay? And also CUDU and edge computing and applications are everything inside the campus. And we are having private 5G license, okay? So that we can do everything by ourselves, even provide SIM card. Okay? And we can, of course, use commercially available 5G phone, but also we can introduce the latest technologies such as AR, VR, and also automated driving vehicle inside the campus and developing new use cases. So in the campus, we have, in this month, we have 3 automated driving vehicles inside the campus and running all the time. Okay? As well as 5G, we have a next generation intelligent transport system inside the campus for innovating smart cities. So the ROSA unit includes, of course, LiDAR and the camera sensors, but as well as V2X, including 60 GHz millimeter wave. Okay? And by using this kind of ROSA units and automated driving vehicles, we are developing next generation use cases such as ITS and car sharing. Okay? So in the edge computing, we have developed digital twin, real-time digital twin of the campus. This is not CG, computer graphics. This is real-time digital twin, and the latency between physical layer and the cyber layer is just less than 100 milliseconds. So it's almost real time, okay? And we have now extending this kind of system to other campuses of Suzuka Kedai and Tamachi. And this is an example of measured throughput inside the campus, okay? And in the red circle, you can see the millimeter wave and sub-6 RU, okay? And this one is an automated driving vehicle, and automated driving vehicle equipped with of course, LiDAR sensor, but also the measurement system of both millimeter wave and sub-6, and can do drive test everywhere automatically. Okay? And the right-hand side shows just one example of measured throughput, and total throughput is more than 1,500 megabps inside the campus. It's quite good. Okay? And this is an NSA system using both LTE and 5G NR with sub-6 and millimeter wave. Okay, but as you expected, there is a problem of millimeter wave coverage. Okay? So left-hand side is a line of sight from a radio unit. Okay? And the measured throughput is quite good in the line of sight area. Okay? But in the right-hand side, most of the area is non-line of sight, and even there is a trees along the street. Okay, so we need coverage extension scheme especially for non-line of sight area. Okay, so for this purpose, we already introduced analog repeater for coverage extension. unfortunately, this is not from Airgain. Okay. Then, as in the previous slides, we have introduced set of repeaters with base station side we call donor unit and also UE side service unit. Okay, so this repeater is very primitive with only beamforming capability in the donor side. Okay, and this one is low cost, low power consumption. Power consumption is less than 50 watt. So that this kind of solar panel, this size of solar panel is enough to activate this analog repeater. Okay, and this one is showing the photo of the campus, and in the red point there is there are many radio units, but we will focus on the one radio unit located in the red pin. Okay, and there are, as you can see, many blockers, buildings inside the campus, and also high-rise trees inside the campus. Okay, and we decided by using the radio designers, okay, and firstly selected yellow pin for repeater 1 with donor unit and service unit, and the second one is blue pin for repeater 2. Okay, so we tried to use 2 repeaters to extend the coverage to cover most of the major part of the campus. Okay, then this is the result of measurement throughput. The left, so first repeater is used to extend the coverage from east to west. Okay, and the second repeater is used to coverage from south to north. Okay, the left side is without repeater. The throughput is very low, less than 200 megabit per second. Okay, then introduce first repeater. Okay, east-west is perfect. Everywhere more than 1 gigabps. And south with the second repeater, and this one is multi-hop topology. The 2 repeaters, okay, enabled something like a carpet-wise coverage of everywhere over 1 gigabits per second. Okay, so this is excellent of the repeater technology. Okay, and lastly, I would like to propose or share 2 technologies that will come in the 6G, something like an extension of the current 5G millimeter wave repeaters. Okay, the first proposal is massive repeater MIMO. Okay, so maybe the current one is using repeater for coverage, basically coverage extension. Okay, but if we have multiple massive repeaters, then we can use that kind of repeaters to enhance data rate capacity. Okay, so deploying massive millimeter repeaters activated by renewable energy. Okay, maybe capex is a little bit high, but opex we don't need to care about the power consumption. Okay, then create artificial propagation channel to enhance capacity while reducing multi-user interface. Since we can control propagation path, okay, then we can achieve both capacity enhancement and also interference reduction. Okay, that's very novel point of this technology. And we did simulation in the right-hand side. I skipped the details about the condition, but black without repeaters. Okay, then blue is a single hop with massive repeater, and red is a multi-hop with massive repeater. Okay, So as you can see, the capacity is more than 20 gigabit per second everywhere. Okay? So this technology is excellent for capacity enhancement as well as coverage enhancement. Okay? And the second scheme is dynamic on-off. Okay? So maybe the middle, you can see the photo of Shibuya area. Did you go? Shibuya? Shibuya, the population becomes mostly like before COVID. Okay? There are many users. Okay? And in this kind of area, we can create coverage by using repeaters. Okay? But in the midnight, population is small. Traffic is small. In the daytime, traffic is very high. Okay? So that we can control, resource control, we can introduce resource control to reduce OPEX. Okay? So dynamic switch on-off of repeaters can be served for energy saving by service management orchestration. Recently, this one is called RIC. Okay? And AI is used for auto-config and also generative AI for data generation for dynamic radio resource control. Okay? On the right-hand side, you can see the simulation results in the Shibuya area. Okay? It starts from the midnight to midnight. Okay? Then the vertical axis shows the energy consumption. Okay? So without this kind of technology, the energy consumption is flat. Okay? But with this kind of technology, reduces energy consumption dramatically. Okay? And in the case of network-centric on switch, it reduces more than 19% in the midnight. Okay? I think this kind of technology is sustainable for 6G. Okay? That's all for my introduction. Thank you very much.
Thank you. Thank you so much. The next speaker, Dr. Jung-Han Kim, friend, colleague, and professor at Korea University. So you can advance the presentation here. There you go. You want to introduce yourself a little bit first?
Thank you very much for coming here. So it is my great pleasure to be with Dr. Alessandro again. My name is Jung-Han Kim, and I'm now at Korea University. So before joining Korea University, I worked at Intel for 2.5 years and reporting to Dr. Sadri. So today, by now, Professor Sakaguchi discussed about the antenna and propagation issues in 5G and 6G. But now I would like to focus on the AI because we are talking about the communications AI. That's why I'm preparing my slide with AI. So the title is AI Trends for Sustainable and Autonomous Networks. So as I told you before, I'm in electrical engineering department. However, I received my PhD, bachelor's from computer science. That's why my research is a little bit focused on the higher layer technology, including physical layer. However, today we will focus on the AI. First, we want to know what is the key AI method for communication networks. So the question is that how AI is being used in mobile networks. So when we try to use AI techniques in mobile communication systems, then we need to think about the latency, we need to think about the security, connectivity, and battery. So if you want to use AI technology for repeaters or base stations or the other network component, then we need to think about the latency, and we need to think about the security issue, we need to think about the coverage issue or connectivity issue, or we need to consider the energy efficiency. That's why these topics are our main objective in the use of AI for communication networks. The first potential research architecture in AI is federal learning, which can aggregate all the learning parameters into one single servers. That's why nowadays we are extending our network coverage by adding more and more nodes. That's why conducting the AI training in a single machine is not possible in general. That's why using federated learning is essential in this case. And post-training quantization is also important. As you all know that nowadays we are living in the ages of large language models, right? So in large languages model, we are already done all the training in OpenAI or the other major companies. And after doing some training, pre-trained model will be deployed and we will gonna use it. That's why post-training quantization is very important to utilize the technique in our mobile cell phones or network devices. And transfer learning is also very important because once we are done for the training, then doing the training in other part is time consuming and energy consuming. It's not efficient. That's why in the other part, if we already done for all the training, then we have to reuse that one. That's why transfer learning is also essentially required. So then, what's the next topic? So the learning for the sustainable and autonomous mobility control. So in my research lab, you are most likely focusing on the mobility control or autonomous mobility control with the reinforcement learning algorithms. This is required because in our country, South Korea, so we are trying to use autonomous mobility devices to extend the coverage. That's why it works as a mobile base station or it works as the repeaters. That's why that kinds of the deployment of the drones is very important for us. That's why autonomous control for multiple drones is essentially required. That's why our lab is working on the coverage extension with based mobile drones. In addition, we are talking about the urban air mobility and UAV for Amazon delivery. So these devices should be coordinated and cooperated in distributed way. So our lab is publishing a lot of work in terms of this autonomous and sustainable mobility control. And last topic is quantum machine learning. So this is another thing what we are trying to do in our research lab. So in mobile devices and network devices, neural networks are widely used for the AI computation. So below, you can see the classical neural network, but in our lab, we want to design the neural network with the concept of the quantum computing. Then we can design the new architecture as you can see above. So what is the benefit of quantum neural network? The first one is that we can realize the faster training. So in conventional neural network, we are doing the backpropagation-based iterative optimization. However, in quantum, we do not have backpropagation based on the architecture characteristics. That's why fast training can be realized. And then high scalability, because we can design the neural network architecture with a smaller output or size. It means that when we use this one for the reinforcement learning, we can realize the convergence in a fast way, even though we have high action dimension. Lastly, simply we can use small number of memory spaces. So when you start to think about the quantum computing, you may think about the supercomputers or something like that. However, in startups, nowadays there are some company who is making the quantum device is with only 1 qubit, 5 qubit, because they want to use the device for the mobile platforms. That's why using fewer parameters is very important because we can realize the lightweight computation. So as you can see the right-hand side, this is our real-world simulation result. Red ones are the performance of the quantum. Blue ones are the performance with conventional multi-agent reinforcement learning. When you look at the left one and right middle one, even when the action dimension is very small, quantum shows the little bit lower performance than the conventional one. The reason is that the qubit manufacturing is not good enough yet. We have some noise for the qubit computation. But as time goes by, we believe that it can be better. But as you can see in the most right-hand side, quantum computing performance is much higher than the others when the action dimension is huge. It means that if our RL application has a lot of huge and sophisticated action dimensions, then only quantum computing-based neural network can solve the problem. That's why in the future AI application, we know that all the state information, action dimension, the information, those are quite huge. That's why using quantum is better than the others. And then, up to now, we talked about the quantum computing applications to the AI, neural networks, but now in communications, we're also talking about the quantum a lot nowadays. The first one is quantum teleportation. By using the technology, we can transmit quantum information in a very short time over the channel. And then we are thinking about the quantum internet as well. This is mainly for the quantum repeater design for new internet architecture design. So the advantage of the quantum repeater is the fast and energy efficient. So as you can see, IEEE Spectrum paper in the right-hand side, quantum repeater is a major part of the research in new quantum internet architecture design. So up to now, I just introduced my research and future application of AI in communications. Because Professor Sakaguchi talked very valuable result in communication and talking propagation in 6G, but in this case, I would like to introduce the AI concepts in 6G or communication and networks. Thank you for listening to my presentation.
Thank you so much, Jung Hong. So maybe we can start with the introduction of yourself, Mr. Mahmoud, and Dr. Sharif, you didn't introduce yourself, so we go through that, and then I have some questions for you guys.
Yes.
Go ahead, Mr. Mahmoud.
Thank you, first of all. Thank you for Mantel and for Airgain for inviting me for this session. My name is Mahmoud Azijali. I am acting executive manager in the strategic planning unit in the Telecommunications Regulatory Authority. And I worked through different departments within the TRA, the Telecommunications. I was in the type approval, and then for some years I was in the quality of service department. Now I'm in the strategic planning unit.
Wonderful, thanks so much. And Dr. Sharif?
Sure. So, yeah, my name is Sharif. I'm actually with senior strategist with Omantel and the technology strategy and innovation team. Joined Omantel 2016. Before that, I was in the US and Verizon headquarters. I was responsible or senior manager for the network device evolution team in the headquarters in New Jersey. Before that, I was in Bell Labs, also in New Jersey, Murray Hill, for about 10 years. I was leading technology introduction for both Verizon and AT&T, the trials specifically. I witnessed the introduction of the LTE in the US, introduction of VoLTE, voice over LTE, and the beginning of the 5G standard build-up in Verizon, and the 5G before the introduction. Then I witnessed them from the other side of the world when I joined 2016, launching the millimeter wave. Talking about the millimeter wave, I saw them launching. Before that, the preparation was done in part of what I was supporting. Before that, I was in the academia. I see here a lot of professors. So I was in the academia, but it was too early. I was in CUNY, professor, City University of New York, for 2.5 years or almost 3 years. Before that, I was doing my study, also PhD in electrical engineering. So, so this is.
Thank you so much. Thank you so much.
Welcome.
Okay, so to kickstart, maybe some of the questions, the most obvious one, maybe in terms of the research, certification, type approval, deployments. How do you see, or how do you compare the challenges that you had when we were talking about 4G, and now we're talking about 5G, and what you see in the 6G? In each area, I mean, we're talking about Japan, Oman, from a regulatory standpoint, and also Korea. So, what is the main challenge, and how do you compare them together, right? Maybe you start with the certification.
Yes, I can start in regard to the in Oman in general. One of the challenges, I mean, throughout the years since the introduction of the mobile and the start of 2G, and then people were demanding the service, and then came 3G, and the demand also, I mean, increased, and 4G came along. As Dr. Sharif said, Oman is a wide country, different terrains, and we have a lot of rural villages, rural areas. And every time we think we fix the problem, we were able to cover those with certain technology. A new technology comes and the new challenges come with it also. And people quickly adapt to the new technologies, and they demand the new technology. They see the old one is useless for them. So it's a continuous journey, I will say, and as long as the technology evolves and improves, the demand will be there.
Very good, thank you. Dr. Sharif, maybe in terms of deployments, what challenges did you experience during the 4G deployment, and would you see it now in 5G?
Okay, the story of the 5G in specifically Oman and Omantel specific deployment was a very effective and to the point from 2019. So to the extent that while the standard was, the 3GPP was, the license was, the release was ready, our key partners, the equipment makers, were ready at the same moment in 2019, end of 2019, November, to deploy. And the deployment was not just for a press release to do in order to say, we have done it, we are the first to do it. It wasn't like that. And as I always say, it wasn't for a beauty contest. It was to solve a problem that we have, and which is the fixed wireless access. There was a problem that we had a lot on our list. We call it a back order of homes that are raising their hand that they need coverage. And it is due to some in rugged terrain, some in new areas. You have a solution which is fiber. Yes, but it will take years. It will take a lot of municipality work and a lot of budget that you don't have. So otherwise the service will come to our customers very expensive. So the solution on hand was to offer fixed wireless access. Fixed wireless access was always offered since even the 3G time, but it was a failure. And 4G, failure. All the way till the 5G, we saw this. We saw the opportunity. The pipe of the 5G is bigger. So what we got, of course, not because the TRA Oman is here, but the vision also of TRA Oman to give us at the right moment the spectrum and to give it to us with the right way and organize it fairly between the operators that exist and that will exist. Okay, so it was planned very well that all those aligned, we were able to launch the service. And the service was launched with the fixed wireless access on mind. Actually, the first application was fixed wireless. We didn't offer it for EMBB. And once we launched it, in some areas, the C-band, 100 megahertz in Masira, I believe, was congested because we loaded it with more than 200 houses.
Wow.
So it was something as a surprise to us. The 5G, and you try to Google or ask someone, do you have a congested C-band? And the whole world said, no. What are you doing? Like how you got congested? Because actually the fixed wireless access brings two things. Number one, easy, no mobility. Thank you. Mobility, we are very good in mobility, but you're not using it. But the worst thing, you're always on. So the traffic. So we were learning. We saw it. It's not normal mobile. This is always on. And it is strict. And it needs coverage to be stable because the people don't know that this is over, not don't know, but actually they are using it as home broadband service. So you need stability. So this is how Omantel's story and inside and in Oman, the use of 5G was very special. And it jumped from technology introduction to a need that we have to have it in order to give service to our customers. So this success made us a little bit ahead of the game on the 5G. So when we deploy the 5G with fixed wireless access in mind, there was a special way to do it. And that's why we are searching always for tools to support this. And now, after we launched the EMBB, it is a different story. You have the mix, both of them on the same spectrum, supported also by our TRA, that they give us the flexibility to use it either for mobile broadband or fixed wireless access. But the goal in mind, use the resources correctly, as well as enhance the 5G and the services at the end of the
Wonderful.
story.
Thank you so much. Maybe for two, Kay and Junhong, you guys from academia standpoint, how do you see the evolution from 4G to 5G and now looking at 6G? And what do you see in terms of the complexity for the deployments, perhaps, right? What happened in 4G to 5G transition, and what are you going to see from 5G to 6G transition? Whichever you guys want to start.
So on top view, I think 5G and 6G are set, like 3G and 4G were set. And 3G, 4G, as a set, innovated new use cases of smartphone. And 5G, 6G, smartphone is a good market, but 5G, 6G, smartphone is not final use case. And 5G, 6G is use case is cyber physical system, including autonomous driving system. Okay, and AI, NTN, and distributed computing are the tools to create cyber physical system. And the important thing is a platform. If platform is established, a new use case will come easily.
All right.
So I agree with Dr. Sakaguchi. Definitely, with the Gs progressing, when the 6G started to the research by our fellow academia world, it was obvious that we have to stop and think about the Gs that was delivered before. Because they were coming, 3GPP said this, okay, we'll do it. So it was a time to stop and think from the market and end user, the value of each G. So we noticed something that, like exactly what you mentioned, Dr. Sakaguchi. One, not the first G, whatever it was due, 2G and previously, this was very obvious that it was mobility. 3 and 4G was the introduction of you can do messaging as well as other stuff like the smartphone and the applications, the evolve of the application world. With 5G and 6G, like you mentioned exactly, it is more human-centered. So the human comes into the picture. So there is always, you're trying to do, of course, the first one is fixed wireless access, EMBB. This is business as usual. But the rest is the human. How to attach this to the human with either sensors, the IoT, in addition to the Internet of Senses, which is key thing for 6G. So I'm in full agreement about the 5G, 6G story, is that they are one package, it's one story continuing. So it is absolutely, and we have to see how this, and I believe it is the most difficult one because it's not business as usual. It's not data and voice. So it's bigger than that. So in agreement.
Wonderful, thank you. And Junhong, what about your view?
Yeah, in my point of view, in 4G, everybody start to use cell phone without almost restrictions. So we are actively start to use the mobile cell phone in many ways. But from the 5G, we have increased the data rate. However, we need to think about the coverage as well. That's why there is, I think that in previous keynote, it has to mention that 5G failed to have the kill application up to now. But it would be useful for using the technology in fixed wireless access or backhaul. That's why in 5G technology can be used for the backbone or the other infrastructure. In 6G, we are going to the satellite or autonomous devices. It means that we are extending the coverage more and more. That's why the research direction is moving on that way. That's my thinking.
I see. So maybe my first controversial question, what do you see the role and your experience with the FR1, FR2, and now coming up with FR3 for, potentially considering for the 6G? I mean, in the US, we know the FR2, there was a lot of hype behind it. However, it never launched successful way. You have experience with Verizon. They're really not advertising as much. In Korea, I know all the spectrum has been returned back into the government.
Yeah.
So while Samsung was behind it, was very excited about millimeter wave, but they completely went back, right? Japan is coming with a new experience, but now there are discussions of FR3, which is 9 to 16 gigahertz mid-range. So maybe you start with the TRA point of view. How do you see that, and what do you think that, obviously FR1 is successful in Oman, but what do you think of FR2 and potentially what FR3 is going to offer?
I guess it will offer, of course, good quality of service, good, better network performance. But as it was said in the panel, we need a killer application. We need not to rush into auctioning the frequency. For example, in Oman, I was just discussing with the Spectrum team in Oman, and they told me in Oman, for the millimeter wave for RF2, it was because there's no lot of applications and we don't want to stop the innovations. We give the operators the band for 2 years to test it, to have the applications. I mean, during these 2 years, it will be free of charge. There's no charge for it. It's just to encourage the operators to look for the right applications, also to wait for the market to have the correct devices. So we try to have some strategies to not rush into auctioning and monetizing getting the return from the spectrum, but to help the operators also to use it effectively and to the benefit of the consumers.
Wonderful.
Yes.
So Junghong, maybe experience with the Korean MNOs.
Yeah.
Why do you think that there was so much hype and now they completely let go of it?
Yeah, the reason is that the usage of that spectrum was not that good. That's why the government thought about the business successfully in the frequency. But however, the business was not that good in 3 major service providers. That's why they let return all the frequencies. But however, when we go to FR3, I think that we have more chances. And then, even though they returned the frequencies, the ETRI or the other government research institutes start to think about the use of the technology in fixed wireless. That's why I believe that the technology is still doable in here. But the FR2 was not successful in common users, general users.
Commercial use. Right?
Commercial use.
Yeah, I see. So Dr. Sherry, as an operator, where do you see FR2 and FR3, in your roadmap potentially?
Sure. So FR2, working under the umbrella of TRA as well, we have been doing on FR2 tests maybe before 5G standard finished. 2017 was the first trial we have done in our old headquarters with millimeter wave with one of our partners. And it was a proof of concept. So we are convinced that FR2 is having a certain usage, and it will resolve cases for us. All the way till multiple trials, pre-commercial, all the way till all our key vendors implemented pre-commercial in the field. So that makes a proof that we are interested in millimeter wave. And all of them are under our TRA support. And the latest is what Mr. Mahmoud mentioned. This is very important, is that we are with the TRA. We have 2 years to prove that we have a use case for the millimeter wave. Why? Because the whole world is in doubt. We don't know. Assume we will give it for FWA, fixed wireless access. Okay. We have a congestion and fixed wireless access. What do you do? 100 megahertz not working? Install another 100 megahertz mid-band. Okay. Congested. By the way, I'm saying truth. And Huawei team, part of it is here. They know the pain. So another 100 megahertz in 2.6, congested. Okay. Then what do? Then you go to someone like Mr. Ahmed and say, stop sales. His consumer team. Stop sales. We cannot support you. Okay? And wait till the fiber comes. Because we don't have other tools. So this means churn. Our customers will leave or will not be satisfied. So our job in the strategy team is to offer a tool to our planning team. So the tool, wireless tool, is the millimeter wave. 200 is not working, I'll give you 800. Because this is the block that we will take for 2 years by the TRA. 800. This will give you enough life to switch to fiber, take your time, do your economics correctly. But the trick is we have no full confidence that the 800 megahertz will be working and stable. Why? Because lessons learned is that the home broadband users, they need stability. So, you have a tree that is moving beside you, millimeter wave will not be able to penetrate the leaf. We know that. That's from the laws of physics. So you need other solution. The other solution, we talked about it 3 hours ago. So you will need the planning to be with a solution in mind. You use active equipment and extend with the repeater. If you go to 6G, absolutely, what I heard was brilliant about the 6G introducing in the standard a support for the repeaters and giving through the Open RAN or other intelligent entities the ability that currently we cannot give it with our 3GPP through the 5G standard. So this is something in mind. It has to be there. Why? Because FR3 will even make it more difficult for you. So talking about FR3, this is science fiction. So this is also in conjunction. So and we have to make our mind, things are complicated, and that's why when you start looking at 6G, you will find even the talks still over the non-terrestrial network. They went even beyond. So all of that has to work together. So NTN plus you have your terrestrial network beside supplemental coverage using advanced technology similar to smart repeaters. And all of them should be having a capability of going to layers that they couldn't go before. So they need to talk to each other, all the entities, from NTN all the way till the smart repeaters. So this is the challenge in mind.
Right. Thank you.
We're looking for academia to resolve it.
Thank you so much. And Kay, maybe last 30 seconds. I think we're at the end.
Okay,
what is your view?
For recent 40 years, from 1980 to 2020, the carrier frequencies increased gradually, step by step. But in the 5G, jumped. That jump is too big. And so that going back to FR3 is a natural way to improve technologies. But in the 5G standardization, maybe 300 or 200 guys discussed a lot how to use millimeter wave. Okay, so that millimeter wave is basically not for the uniform coverage, but for the hotspot or special use case. Okay, and also control plane, data plane splitting is mandatory to use higher frequency. Okay, but at the deployment of the carrier after 2018, they forgot. That's the problem.
Right.
Yeah.
Thank you so much, Dr. Sharif. Maybe you can get some
Definitely.
assistance with the experts in millimeter wave.
Looking
As Mahmoud, we're planning to regulate it, so we have some history in deployments. So.
Definitely.
Well, thank you so much. I think we're 1 minute over. I wanted to thank everyone for participating, and thank you for all the panelists.
Thank you.
And hopefully we'll see you next time, next MWC, wherever it is. Thank you so much.
Thank you.